Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Hope you and your family in the best of health. Lecture for grade 8, subject chemistry, chapter number 2, exercise, lecture number 15, and here is Mrs. Saira Jamal. Question number 6 of exercise, write electronic configuration for the following elements. First one is silicon. Atomic number of silicon is 14. You have to see the smaller number. I told you before that the smaller number is the atomic number and the bigger number is the mass number, because smaller number is only the number of protons and the bigger number is the sum of number of protons and neutrons. So you, for electronic configuration, you have to consider the smaller number or the smaller value, which is 14. So 14 is atomic number. Atomic numbers are the number of protons, and I told you before that the number of protons and number of electrons are always same. 14 electrons you have to distribute in these subshells, starting from the first shell by following the F-bow principle. Electron will first fill the 1s subshell, after 1s 2s, then 2p, then 3s, and after 3s 3p. So 1s2 s can accommodate 2 electrons, 1s2 2s2, p can accommodate 6 electrons, so 2p6. After 2p is 3s, and I told you s can accommodate only 2 electrons. The 2 electrons which are left, they will place into the 3p. So total how many electrons are there? 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is the electronic configuration of silicon. Second one is magnesium, atomic number 12. So same thing, 1s2, 2s2, 2p6. Till 2p6 there are 10 electrons. So how many are left? 2 electrons. Those 2 electrons will go to the next subshell, which is 3s. As there are 2 electrons, so 3s2 in the last shell. For aluminium, atomic number is 13. So 1s2, 2s2, 2p6, 10 electrons, 3s2, 11, 12, only one electron is left. So that one electron will go to the 3p, because s cannot accommodate more than 2 electrons. So only one electron is left. That electron will go to the next subshell, which is 3p. You can see after 3s is 3p. Argon, atomic number 18, configuration 1s2, 2s2, 2p6, 10, then 3s2, 12. How many are left? 6 are left. So then 3p6, 6, 7, 8, and then 6, 6, 12, 11, 12, 13, 14, 15, 16, 17, 18 electrons. So there are total 18 electrons. So by following the F-bow principle, you can easily distribute the electrons among the subshells. Question number 7, describe the contribution that Rutherford made to the development of the atomic theory. So for this question, we have to write the complete topic of Rutherford atomic model from book. No need to write the drawbacks, just till the planetary model of Rutherford. Till that topic, the question will be completed. Question number 8, explain how Bohr's atomic theory differ from Rutherford atomic theory. Although I explained this topic in my lecture, but I'm just giving a quick review to the same topic. Rutherford atomic theory and Bohr's atomic theory. First point is it was based on classical theory, and Bohr atomic theory is based upon quantum theory. Classical theory, I told you that this is related to the real objects or real thing, and quantum theory is based on the microscopic thing or the atomic level. Electrons revolve around the nucleus. There is no specific pathway, but Bohr said that electrons revolve around the nucleus in orbits of fixed energy. Those orbits has fixed energy. No idea about orbit was introduced, and orbits had angular momentum. Atoms should produce continuous spectrum, but atoms should produce the line spectrum according to Bohr's atomic theory. Atoms should collapse, atoms should exist. So, you know that atoms can neither be created nor destroyed. So this point is totally wrong. Question number 9, describe the presence of subshell in a shell. And I already explained this subshell topic. So write the complete topic of subshell from book. That will be the answer. Question number 10, state the importance of isotopes in various fields of life. In your book, there are 8 uses of isotopes. So write all those 8 uses of isotopes from book for this question. Question number 11. The atomic number of an element is 23 and its mass number is 56. There is an element whose atomic number is 23 and mass number is 56. We have to find out part A, how many protons and electrons does an atom of this element have? And B part is how many neutrons does this atom have? How many protons? So protons are same like the atomic number, because atomic number is the number of protons present in the nucleus of an atom. So atomic number is 23. It means number of protons will also be 23. Electrons and number of protons are always same. So 23 protons and 23 electrons. How many neutrons does this atom have? So to find out the number of neutrons, we have the formula, that is number of neutrons is equal to mass number minus atomic number. So mass number is mass number or atomic mass. They are same. Okay, don't get confused in these terms. These two terms are same. Mass number or atomic mass. 56 is the atomic mass or mass number, and minus 23 is the atomic number. Answer is 33 neutrons are present in that element. Atomic number atomic number is always equal to number of protons. Number of protons are 23 and number of protons are always equal to number of electrons. So number of electrons are also 23. Question number 12. The atomic symbol of aluminium is written as Al13, atomic number 13, and mass number 27. What information do you get from it? From this symbol Al and with atomic number and mass number, what information do you get from it? So first of all, Al is a metal. Al is a symbol of aluminium, and aluminium is a metal. Its atomic number is 13. Atomic number is 13. Mass number or atomic mass. Mass number or atomic mass, not atomic number, atomic mass is 27. As atomic number is 13, so number of protons will also be 13. Number of protons and number of electrons are always same, so number of electrons are also 13. Number of neutrons are, we can find it out by using the formula, mass number minus atomic number. So 27 minus 13 is equal to 14. Bohr model, we can draw it from these information. Bohr model of aluminium, 13 protons, 14 neutrons, 2 electrons in the first shell, 8 electrons in the second shell. So 8 plus 2, 10. How many electrons are left? 3 electrons. So those 3 electrons are present in the outer outermost shell. From this information, we can also distribute the electrons. Electronic distribution is 1s2, 2s2, 2p6, 3s2, 3p1. So 1s1 is K shell, 2 second shell, and 3 is third shell, which is also called K, L, and M shell. So three electrons are present in the valence shell or in the outermost shell. How many? Three. 2 plus 1 equal to 3. Three electrons are present in the valence shell or in the outermost shell of aluminum. To complete its outermost shell, as this outermost shell, which is the third shell, which is also called M shell, it has how many electrons? It has 3 electrons. And to complete this outermost shell or the valence shell, aluminum needs 5 more electrons. So to gain those 5 electrons is very hard, or it is very difficult, because very large amount of energy is required. So in order to complete its outermost shell, the easiest way is to lose 3 electrons. So it is easy for aluminum to lose 3 electrons. So aluminum will lose 3 electrons and will form Al plus 3 cation, which is also called trivalent cation or trivalent aluminium ion. Plus 3 means it loses 3 electrons. And you know that when an atom loses electrons, it get a positive charge and it is called cation. So all these information means about the number of protons, about the number of electrons, about the number of neutrons, then electron distribution, then Bohr model, and then to complete the outermost shell, it will form which type of ion. All these information we can get from this symbol along with atomic number and mass number. Okay, got it? Number of protons, number of electrons, number of neutrons, electronic distribution, then after electron distribution, ion formation. So about 5 types of information we can get from this symbol of aluminium having atomic number and mass number. If we include the Bohr model, so there are 6. How testing prevailing theories bring about changes in them. Testing prevailing theory bring about changes in them. This is Society of Technology and Science from your book. Dalton's atomic theory explained data from many experiments. Dalton, you know, is the name of scientist, and he presented the first atomic theory about the structure of atom. So he collected data from the experiments which the other scientists they performed, and from that by using that data he performed new experiment. So it was widely accepted discovery of subatomic particles and isotopes proved that. Then later on some other scientists they collected the Dalton's data and they performed experiments, and they found that the some of the Dalton's postulates or the Dalton's ideas about atoms are not correct. So scientists, they did not discard his theory, although we know that there are many, you can say, wrong postulates of the Dalton's atomic theory, but still Dalton's atomic theory we are studying in books. The reason is that actually the Dalton's atomic theory give us a guideline or an idea about the structure of atom. So same, although some of the postulates were, some of the postulates are wrong in Dalton's atomic theory, but scientists they did not discard his theory. Instead, they revised the theory to take into account new discoveries. They use his theory and then they are doing new discoveries. Until today, scientists they are doing new discoveries. So this shows that how testing prevailing theories bring about changes in them. So let us discoveries bring changes in the old theories. Question number 14. How experimental results of some scientists help chemists to formulate new theories and new explanation? This question is again related with the previous question, that the experiments of the old scientists help the new scientists to present or to give new theories and new explanation. This is society, technology, and science. This is the first society, technology, and science of your book of the same chapter. So write it from the society, technology, and science, the first one. Next is think tank. Question number 50. Sodium 24 is a radioactive isotope which is used to diagnose restricted blood circulation, for example, in legs. How many electrons, protons, and neutrons are there in this isotope? Valence shell electronic configuration of this isotope or third shell M is 3s1. Given information are mass number is given, which is sodium 24, mean 24 is the mass number. Then valence shell electronic configuration is given, which is 3s1. 3s1 is the valence shell, mean the configuration of the outermost shell. So we have to write the electronic configuration of the inner shells also, because this is the third shell. So we have to write the second shell as well as the first shell, and then we will put electrons in them. So the first we will reach till 3s. So before 3s is starting from 1s2, then 2s2, then 2p6, and the last one will be 3s1. 3s1 we write because it is mentioned in the question. And the other shells are 1s2, 2s2, 2p6. These shells are called inner shell, because this is the outermost shell or valence shell, and these two shells are called the inner shell. How many electrons are present totally? If we count, so 2, 2, 4, 4 plus 6, 10, 10 plus 1, 11. So there are total number of electrons are 11. So now we have information about the mass number, which is 24, and from the valence shell electronic configuration, we got information about the number of electrons. Then number of electrons and protons are always same. So if there are 11 electrons, it means protons are also 11. And number of protons tell us about the atomic number, because atomic number means the number of protons present in the nucleus of an atom. Then number of neutrons we will find out by using the formula mass number minus atomic number. Mass number is 24, atomic number is 11. So answer is 13. Okay. Question number 60. Two isotopes of chlorine are chlorine 35 and chlorine 37. How do these isotopes differ and how are they alike? We have to mention the differences as well as the similarities between the isotopes. First, differences between isotopes. Properties. Mass number for both isotopes are different. You can see for chlorine 35 mass number is 35, and for chlorine 37 the mass number is 37. Number of neutrons are different. 35 mass number minus atomic number 17, so neutrons are 18. Mass number minus atomic number, mass number is 37, atomic number is 17, so number of neutrons are 20. Mass numbers are different, number of neutrons are different. Natural abundance means in atmosphere, chlorine 35 is abundantly present, or chlorine 35 is present in higher percentage, that is 75%, while chlorine 37 is present in lesser percentage, that is 25% only. Physical properties I told you depends upon the mass number or the number of neutrons. As number of neutrons are different, mass number is different. So mass number difference means physical properties are also different. So these four properties are the differences, or these are the four different properties between the two isotopes, not only the isotopes of fluorine, but all types of isotopes of any element, they differ in these properties. What are the similarities between these two isotopes? Number of protons are same, 17, 17. Number of electrons are same, 17, 17. Chemical properties are same because chemical properties depends upon the electrons present in the outermost shell. So as both have same 7 electrons in the outermost shell, so their chemical properties are also same. Electronic configuration is same because they have same atomic number. So same atomic number means same number of electrons. So for both the isotope, electronic configuration will be 1s2, 2s2, 2p6, 3s2, and 3p5. So the third shell 3s and 3p, 5 plus 2, 7 electrons are present in the outermost shell or in the third shell. Question number 17, how many electrons can be placed in all of the subshells in the n is equal to 2 shell? N is equal to 2 means the second shell, and second shell is also called L shell, and L shell is subdivided into two subshells. Those two subshells are 2s and 2p. S can accommodate 2 electrons and p can accommodate 6 electrons. So we will place electrons to s2, 2p, 6. Total electrons are 2 plus 6 equal to 8 electrons. So how many electrons are placed in all of the subshell? In n is equal to 2 shell. So total there are 8 electrons. So to confirm that 8 electrons are correct or not, we can use the Bohr formula, which is 2n square. So by using the 2n square formula, we will confirm it that either the second shell contains or second shell can accommodate 8 electrons or not. So n value is 2. So by putting the value of n, which is 2, 2 2s are 4 and 4 2s are 8 electrons. So the answer is yes, it is correct that all the subshell in the shell number 2, they contain total 8 electrons. Separately 2 in S and 6 in P, but total electrons number is 8. Question number 18, mass number of an atom indicates total number of protons and neutrons in the atom or in the nucleus of an atom. Can you identify an atom without any neutron in it? Although I explained this question, which is the short question answer, but I'm just going to give a quick review. Yes, we can identify an atom without knowing the number of neutrons in it. How? By its proton count, because all the electrons or all the elements which are present in the periodic table, they are placed on the basis of their atomic numbers, not on the basis of their mass number. The neutron count tell us the isotope of that element. Neutrons are important for isotopes only, not for the identification of an element. Example is hydrogen has no neutron, but we can identify it from its proton count. Proton count means atomic number is 1, so it means it is hydrogen, because in periodic table atomic number 1 element is placed and that is hydrogen. We can find the number of neutrons. If we don't know about it, you have no information about the number of neutrons, so we can use the formula and we can find out the number of neutrons by atomic mass minus atomic number. So by using this formula, what is atomic number? Atomic number is number of protons, which are always equal to number of electrons, and mass number is sum of protons plus sum of neutrons present in the nucleus of an atom. Question number 19, the table shows the nuclei of 5 different atoms. Those atoms are A, B, C, D, E. There are 5 atoms and A has 5 protons and 6 neutrons. B 6 protons and 6 neutrons. C 6 protons and 7 neutrons. D 7 protons and 7 neutrons. E 8 protons and 8 neutrons. Which atom has highest mass number? So mass number is sum of protons plus neutrons. So 5 plus 6 is 11. 6 plus 6 is 12. And 6 plus 7, 13. 7 plus 7, 14. And 8 plus 8, 16. It means 16 is the highest mass number. So which atom has highest mass number? Atom E has the highest mass number, which is 16. Mass number is number of protons plus number of neutrons. Means 8 plus 8 equal to 16. B part, which two atoms are isotopes? Which two atoms are isotopes? So isotopes, I told you they have same atomic number. Same atomic number means they have same number of protons. So B has 6 protons and C has 6 protons. So it means B and C. B and C are isotopes because they have same number of protons but different number of neutrons. B has 6 neutrons and C has 7 neutrons. So neutrons are different, but the number of protons are same. So B and C are the isotopes. C part, which atom has least number of electrons? So electrons, I told you number of protons and electrons are always same. So A has only 5 electrons. So atom A has the least number of electrons, that is only 5. Which atom will have electronic configuration 1s2, 2s2, 2p3? Let us count the total number of electrons. 3 plus 2, 5. 5 plus 2, 7. So number of electrons are 7. It means number of protons will also be 7. So which of these atoms has 7 protons? That is D. D has 7 protons. It means it has 7 electrons. So atom D, which has 7 electrons. Which of the atom contain the most number of electrons? So most number of proton means most number of electrons. So E. Atom E has the greater number of electrons in it, that is 8 electrons. Last question of the chapter. Naturally occurring nitrogen has two isotopes, nitrogen 14 and nitrogen 15. Which isotope has greater number of electrons? So dear students, you know that isotopes are atoms of an element which has same atomic number but different mass number. So as atomic number is same and same atomic number means number of protons are same, and we know that number of protons and electrons are always same. So same atomic number means same number of electrons. So both isotopes will have same number of electrons. They had only, the difference is only in the number of neutrons, but their atomic number will be same. So this was the last question of the chapter. Hope you will understand the exercise as well. Uh, Two chapters of chemistry are completed. So try to learn these chapters properly and do practice of all the numerical problems and the conceptual problems. Inshallah, I will share the MCQs of these chapters, the extra MCQs which are important for examination point of view. Inshallah, I will share soon. Take care. Bye.